The division of polynomials. There are three components on the methods of dividing. There's the divisor, the dividend, and the quotient. An example would be this problem in which x plus 3 is the divisor, 2x squared plus 10x plus 12 is the dividend, and the quotient is 2x plus 4. Now we're going to move on to division algorithm. The formula for division algorithm is fx equals dx times qx plus rx, in which fx is the dividend, dx is the divisor, qx is the quotient, and rx is the remainder. An example of division algorithm would be this problem in which we are dividing x squared plus 3x plus 5 by x plus 1, in which we are going to write it in division algorithm by placing x plus 1 as the divisor, x plus 2 as the quotient, and 3 as the remainder. Now let's move on to long division with a placeholder.
Example 1. You want to set up x minus 2 as your divisor. Then, you want to set up x cubed plus 0x squared minus 5x plus 2 as your dividend. 0x squared is your placeholder since there is no x squared. So our first term is x squared because x squared times x minus 2 results in x cubed plus 2x squared. This cancels out, so you get 2x squared minus 5x because we dropped our 5x from the dividend. Now our next term is 2x because 2x times x minus 2 results in 2x squared plus 4x. Doing our math, we get negative x plus 2 because we dropped our 2 from the dividend. So here, for our final term, we need to find negative x plus 2. So our last term is negative 1 because negative x times x minus 2 results in a 0. Once again, marking that 0x squared is our placeholder since there was no x squared term. Now on to long division with a remainder. We're going to take the term 2x squared plus 1 and we're going to set that as our divisor. Then we are going to take 6x cubed plus 10x squared plus x plus 8, and then we're going to set this as our dividend. Now we need to find our first term, which is 3x, and we get that by multiplying 3x and by 2x squared plus 1 to get 6x cubed plus 0x, which is our placeholder, minus 3x. Now note that we are always subtracting our terms, and we are resulted with 10x squared minus 2x, and then we're going to drop down our 8, and it's going to be minus 2x plus 8. Now onto our second term, which is plus 5, because 5 times 2x squared plus 1 equals 10x squared plus 0x, because that's our placeholder, minus 5. Once again, we are subtracting and we get 2x plus 3. Now 2x plus 3 is our remainder, and for our remainder we have to take, well, our remainder negative 2x plus 3 and set it over your divisor, which in this case would be 2x squared plus 1. So to write out your answer, you'd have to write out 3x plus 5 minus the opposite of your remainder, which in this case would be positive 2x minus 3 over our divisor 2x squared plus 1. And that's our answer.
Now we're going to move on to synthetic division with placeholders. Example number 3. X cubed plus 512 divided by x plus 8. First, we must set x plus 8 equal to 0, and then subtract 8 from both sides, in which we get x equals negative 8. We will then use x equals negative 8 as our divisor, in which we will drop down the leading coefficients of 1, 0 as a placeholder since there are two missing terms, 0 and 512. Then we must drop 1 and multiply that by negative 8, and drop negative 8 and multiply that once again the divisor. We then continue this pattern until we reach the end by getting either a 0 or a remainder. We will then drop 1 as x squared since it decreases from x third to x squared, and negative 8x since it decreases from 0x squared to negative 8x, and then 64 as a normal number. Our quotient would then be written as x squared minus 8x plus 64, and as a restriction, x cannot equal negative 8, and that will be your answer for synthetic division with a placeholder. Some things to look out for when solving are positive and negative signs, in which we are always subtracting using long division and adding during synthetic division. Also placeholders, which are missing terms. An example would be x third plus x squared plus 0x plus 4, in which we are using 0 as a placeholder for that missing term. Variables are always going to be one less power from the original dividend, in which an example would be x third plus x squared plus x plus 4, in which the quotient would be x squared plus x plus 4. We are now moving on to the rational zero test. Example number 5. Fx equals 2x cubed plus 3x squared minus 8x plus 3. We must first use the equation P over Q, which equals the constant term 3 at the end of the equation over the leading coefficient of 2x cubed at the beginning of the equation. We then set the factors of 3 over the factors of 2, in which we get plus or minus 1, comma plus or minus 3 over plus or minus 1, comma plus or minus 2, in which the possible roots for the factors of 3 over 2 are plus or minus 1, plus or minus 3, plus or minus 1/2, and plus or minus 3 over 2. We will then use synthetic division to test these roots out until you get one that has a remainder of 0. So first, let's test out 3, and as you can see, we get a remainder of 60, so this is not a factor. Another root we're going to test out is negative 1, and as you can see as well, it has a remainder of 11, so this is not a factor. Now let's test 1, and we bring down 2, 3, negative 8, and 3, and we synthetically divide, and as you can see, we have a remainder of 0, so 1 is a factor of the function. Since x equals 1 as a factor, factor fx as fx equals x minus 1 parentheses or factor 2x squared plus 5x minus 3, in which this is our quotient from our synthetically divided example, equals, we have to factor this out, x minus 1 parentheses 2x minus 1 parentheses x plus 3 parentheses. And this is our answer for the rational zero test.